We have one more video dedicated exclusively to torque. Assuming each system is pinned at the center, determine the net torque for each of these systems. So there's a pin at the center of each of these, and we're wanting to know what the torque is. Torque, as we recall, one equation for it is the effective lever arm multiplied by the force. And the nice thing about wheels or pulleys is that the radius of the wheel is the effective lever arm. You see on this first diagram here, what's the effective lever arm? Isn't it right there, which is perfectly at right angles with the force. What's the effective lever arm up here? Isn't it right there, which is perfectly at right angles with that force? And what about that effective lever arm? Perfectly at right angles. That's one nice thing about wheels. And so what we need to do here is we need to figure out what the net torque is. So that's going to go R times F for each of these. 0.6, the units are right, meters and newtons, so I'm going to leave them off when I do my work. I'm going to report them though when I show my answer. Let's do the 50 first. 50. So what's that? 0.6 times 50 is going to be 30. We'll total these up at the end. And that's clockwise, isn't it? That would cause the thing to go clockwise. What about the 20 Newton force? R is 0.6 times 20, and that's going to be 12 Newton meters, also clockwise. But look what the 30 Newton force is trying to do. 0.6 times 30, that's 18 Newton meters, but that's trying to go counterclockwise. So somebody's got to be positive and somebody's got to be negative here when we add all these up. So I'm seeing 42 minus 18. The net torque here is going to be 24. And now we make sure we put our units in there, Newton meters. And who wins? Clockwise wins, because clockwise is bigger. So that's how we do that one. Let's look at the one in the middle. Here we have a more complicated system, but it looks like the outer radius is 0.3 and the inner radius is 0.1. So let's see what we can do here. Let's go 30 newtons, that's the force, times 0.3. Can we do that in our head? 30 times 0.3, 9 Newton meters. We'll put the units on at the end when we add them all up. 9 Newton meters, and in what direction is that? That is counterclockwise, isn't it? Like that. So we got that one taken care of. How about 20 times the effective lever arm for that is only 0.1, so that's 2, and that is also counterclockwise. And then we have the 10 Newton force, and its lever arm is 0.3, so that's 3 Newton meters. That one's clockwise. So when we add all these up, what does that give us? That's 11 in that direction and 3 in that direction, so that's going to be a net of 8. 8 Newton meters counterclockwise. Incidentally, when you're doing torque, you cannot change this to joules. You absolutely cannot do that. And the reason is because this newtons and this meters, they are cross-producted with each other. And when you cross product those, you don't get joules. When you dot product them, like when you do work, then you do get joules. Do not change this to joules whenever you're doing torque. There you go. All right. So what we're seeing here is that we have different radii and different forces and different directions for torque. And we just have to make sure that we apply all these correctly. Let's take a little bit of a shortcut here. Look at this one. Here we have 4F and 3F, and they have the same lever arm, which is 2R. They're going opposite ways. So the net is F multiplied by 2R. That one and that one feed into that one. I'm taking a shortcut here. And what does that give us? 2FR. Who wins? Counterclockwise wins, because 4F is bigger than 3F. So those we've taken care of. And then we have a 3F, all by itself with a radius of 3r. 3f, let me double underline that so you can associate those, and the lever arm is 3r, and so that multiplies out to be 9fr. And in what direction is that? That is trying to be a clockwise torque. I think when we add these up, we don't have units on here, so we'll just leave them in terms of variables. 9 in one direction, 2 in the other. I think that gives us 7 FR in the clockwise direction.